Alright, let's see. That was in 2-2?
Yeah.
Or 2-3? 2-2?
2-2B.
Number 18? Yeah. Alright. That guy's like, I am here. Okay. Braille numerals, blah blah blah. Numerals proceed by backwards. L dot symbol. The following shows the basic elements for Braille numerals and changes. Okay. So this is all the possible dots you could have. And if you see this number in front of something as a blind person, you would know that that means, well, if you see it with your hands, that would mean that's a number coming next. You with me? So that's this symbol here. This symbol here is not part of the number. It actually tells you this is a number coming. Is that cool? So do you see how each possible place is a block of 6? So like this is one place and that represents the number 1. Now thankfully, Braille lives within our Hindu-Arabic place value system. So far I got 1, and then what's this? Now this is where things get a little interesting about placement. Are you with me? So one thing you can try to do for yourself is to kind of block these off so you can kind of get an idea of where that is. But what do you think that number is? It's a comma. Good. It's not a number. I love it. You guys all with me? Yes.
That would make it a placement type of.
Yeah. It's a place value system. It's not a different system. It's just different numerals.
One of the questions was asking, is this an additive?
For Braille or for a
Not
different?
For Braille, for a different one.
Okay.
I was just wanted to put that.
Yeah, this sucker is just rewriting a number 1 million something or other, where instead of 1 we have a tactile thing, right? Something you can feel, comma, and then of course that would be 4, blah 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 blah. So every one of these, it kind of makes sense. It happens after every 3 because that's another comma, right? So that confuses people sometimes. People sometimes think that's a number to themselves. Okay, is that better?
Yeah, I totally agree.
Cool, I like it.
Thank you.
You're welcome. So this is kind of like Chinese, where in the problem they go, I'm going to make you do a problem and explain it to you at the same time. You're like, oh, thank you, but yeah. Anything else about that? So there's the 1,400,000,000 and blah blah blah. You got to keep going. So we got the first few pieces of that. Okay. Of course, you're not going to know if it's million or billion or whatever until you get to the end. Yes. Okay. Anything else from homework stuff?
Section 2.2B. Just I am confused about the number 12. Man.
Oh, this guy.
Yeah. Number 12.
Yeah.
It's like a 0 on the bottom.
How many places are here?
3,
Huh? No, it's 2.
2.
Yeah.
Yeah, it's so close together, it's hard to tell.
Right.
Yeah, it's too hard to, I confuse.
I'm with you. Yeah. Well, there's two places there.
2 places.
Yeah, they would have to put this blueberry much further away to mean there was 3 places. Do you see? This is the number what? This is 6, and it's in the 20s place.
Yeah.
And this is of course 0. It's in the 1s place.
So is it 60 or no?
No. What place is this? 20s, and you have 6 of them. So it's 6 times 20. 120. So the first part of any of these is making it in Hindu-Arabic, and then it's just 3 problems built in, right? Do you guys see what I'm saying?
Yeah.
So in this one problem, there are 12 problems. Yay! It's a very mathy thing to do, I know. You guys okay with that? You don't have to know how to go straight from Egyptian to freaking Roman. That's, change stuff into ours and then go to whatever else you need. Yeah.
For D, right on top of it, right on top. D is right on your top corner, top right corner.
D.
Of the entire board.
Oh, that D up there.
Yeah.
So the previous problem, okay.
My bad. How do you know, like, those numbers are, yeah, they're very close.
What is
so I
this?
think
What is this?
0.
0. This is a place? This is a place. This is a place.
Which one, just the two or the,
Yeah.
that's a place.
This is a 0, correct?
Okay.
That is a place, which means this is a place, right?
Right.
Now, this is a place. If they meant these were in one place and these were in the next, they needed to have more space. Does that make sense? So this is the 1s, this is the 60s, this is the 3600. Why could they put these so close together? Because that's a natural kind of break. That's a 0, right? Place, place, place. You guys with me?
So there's 3 places.
3 places. Okay, maybe.
And what about a,
Here? Okay, all right. I need you to see. The zeros are each in a place, otherwise they wouldn't be there, correct? So there's a place here and a place there. Is everybody with me? That is another place, yes. And that is another place. So there's 4 places. Yeah. Looks like a very happy frog. Belly mouth? I don't know. Or whatever it looks like to you. I'm sorry. That one, I need that one to be really clear. I will agree that some of these it's not clear. I will agree with you. The most important thing is whatever it is you think it is, can you do it? Can you put it together? So when I do a quiz or a test, it will be very clear how many places there are, right? Yes?
I forget, how do you know what your, like what, with the Romans, which ones are grouped together?
Oh, again, the very first thing when you look through Romans is you look for any pairs where the first one is smaller than the second one.
Like the one,
So I would do this. Is M and C, are they cool?
Mm-hmm.
C and X, is there smaller in front of a bigger so far?
No.
M, C, C, X. What about XL?
Yeah.
Underline that.
okay.
Everything else is additive. Do you see that? If I find a pair where the first piece is smaller than the second, that means subtraction. So isolate that, because everything else will be addition, because Roman is basically additive with a little subtraction side note, right?
What if nothing's subtracted?
Say again?
What if nothing's subtracted?
Then everything's additive. So if I would have put this,
Oh, okay.
turn this around, if this would have been LX instead, then it would just been additive, right? 1,260, blah, 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 right? Is that cool? Yeah. So the very first thing you look for is there a pair where the first dude is smaller than the second dude? Let me kind of underline that. And now I can just add, subtract, add.
Okay,
Yeah,
thank you.
you're welcome. And we've talked about Romans. We've talked about they could have improved it. But it was a lot of shit just to create it from nothing in the first place. Are you with me? So sure, it's easy for us to go, oh yeah, good try, you know. But you know, we're living with many years experience, all right? Millennia. Okay. Anything else from homework? Okay, so what I want to do, let me see if I can get you guys to play along. I think somebody left, which sucks, because they had an even number of people. Yeah, well, all right. Well, too bad. I need everybody to group up with one other person. Find one other person. Kind of sit together. Exactly one other person, except for one group's going to have 3. There's somebody left. Damn it. How's everything going? Fine. Okay. Okay. Cool. Uh-oh. All right.
Not that I don't mind.
You might be the 3. Yeah, that's cool. So everybody got 2? Oh, okay.
Do you want to put there?
Sure. Yeah. Oh, good. You guys are good. Okay. Okay. So, please send up one person. You're gonna grab some stuff up here, okay? Let me see that. If I would have had more time, I would have separated this already. Grab like 6 of those. Here, let me try to grab some for you. 20, 50, good. blocks yet?
Yeah.
Okay. You only need 2. That's fine. Okay. You're good. I'll get the little ones, because the little one's gonna be too much for you to handle.
5 of these and then 2 blocks.
Yeah. 2 blocks, 5 flats. So the cubes, flats, and longs. Yes, 5 flats, 2 blocks, and then 6 of these. Yeah, don't worry about those. Yep, the cubes. I'm sorry. Yeah, cubes. Big cubes, yep. Big 2 of those. 6. Should be enough, okay. So what do we got? 2 blocks. Thanks for playing along, everybody. These, 6 of those. Okay, 2 blocks. 6 of these, 6 longs. And 5 of these. Alright, 2 blocks. 5 flats, 6 of those. Alright, cool. Should be a decent amount. Number, okay.
It's like
No, I never.
All right, guys. All right, let's see. So let me plop out some of this for me. So, what base does this represent? Huh? Good. Base 3. We looked a little bit at this real quick last time, but you didn't have your own to kind of play with. Let's just take all of, where did I put them? Over there, okay, that makes sense. Alright, so obviously, we got the ones place. Let's see if this is gonna work yet. We got the, what's this? Threes place, and then we got the nines place, and then we got the, oops. Haha, 27th place, okay, I love it. You will have similar manipulatives, except of course yours are going to be based on, that's a very sad looking thing. Yours is going to be based on base 10. You're going to have longer, your longs are going to be 10 long, your flats are going to be 10 by 10, your cubes are going to be like, I've got some in there, we just, for some reason, we're going to have a complete set. So maybe I'll pull them out here in a minute. All right, so I want to do a couple really basic stuff with you. So let's do this. I don't know how many of these I gave you, but everybody should have enough for like, does everybody have like 11 of these?
Yeah.
All right, so count on 11 of these. Jeff, what do you think? Counting how many total you got, you don't need that. Okay, that should be fine. All right, so I'll see if Jeff can count. All right, So this is 11 base 10. This is our place system, right? 1, 2, 3, 4, 5. Is that good? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I could just count, my job would be so much easier. There we go, Jeff. Okay. So that's 11 base 10. Are you with me? Because we can count them until we get to 11. If I was in base 3, what would the highest single digit be? 2. So if I start counting in base 3, I would start 1, 2. The minute I pick up another one, what does that become? What shape does that become? Yeah. You guys with me? So then I could, let's do this. I've got a 1's place, I've got a 3's place, I got a 9's place, and I got a 27. I also have a need for water. Hold on. Right. So when I start to count these, whenever I get to 3, so I've got a, is this my question? Yes. So whenever I get to 3, that actually goes to the next place. So now I've got one of these. Let me replace those with one of those. And then I keep going, right? Is everybody with me? So 1, 2, 3. So now I replace it with one of these. Bam. 1, 2, 3. But now what's going to happen, of course? I replace this. Is everybody with me? Yeah. With one of these. Yeah, there. Oh shit, I lost my. So now what is this then? This will be one of these, 2 of those. So what number base 3 is that?
101.
101.
2.
2.
Sorry.
Right? Do you see that? So every group of 9 we've got is this place. If I had a number that had, all right, let me stop right here for a second. So this would be the number 1, 0, 2, base 3. Does that work out? I have 2 1s, no 3s, and 1 9. What's 2 1s plus 1 9? Freaking 11, which is what it was, correct? All right, let me stop. Is everybody semi with me? Okay, so now this time count out. Does everybody have enough for, what are you trying to do, buddy? Let's do, I definitely didn't give everybody enough to go beyond that, so let's do one more. Count out 3, 6, 9, 12. Do you have enough for like 16? Yeah? Okay. Try to do exactly what we just did, piece by piece. Alright, so we catch up to you guys. So I get 9. So that's one of these guys. And then I get 3, 3, and 1, right? So these 2 become 2 of these. Bam, bam. You guys with me? So it becomes an organizational problem. It becomes, do kids like blocks?
Yes.
So you can see how this is informative, educational, but it's also just freaking playing with blocks. And our brain enjoys gathering and grouping things. It's part of what we're just hardwired to do. So this is kind of fun, especially for young kids. And they have other versions of this, like some that could click in together and stuff, and that's very tactile, that's very click, and you're like, that's very satisfactory. So what does this end up being then?
1, 2, 1.
Yeah, 1, 2, 1. And you can do it basically, and then you can check it and so forth, but now, okay, we're gonna go a little bit beyond where we've gone so far. Could everybody, what would 3 be? Just pick something that would represent 3 for us. So let's see, I picked this, that's 3. So everybody should pick this. Isn't that 3? Now in base 3, that would be 1, 0, but this represents 3. Are you with me? What do you get? So what is 3 times 3 in base 3? So real quick, what does 3 times 3 even mean? Like, what is multiplication based on? Do you guys know? Beautiful, exactly. It's repeated addition. So instead of going, instead of saying 8 times 9, I could go, well, 9 plus 9 plus 9 plus 8 times. But then the shortcut we created was 8 times 9. We know it's based on multiplication, right guys? So 8 times 9 means, imagine you have 8 9s, you're going to add them all up. And then we just memorize what the hell that shit is. It's multiplication tables, right? So 3 times 3 means I have 3 of the things that represents 3, correct? So if I wanted to do 1 0 times 1 0 base 3, yes? I would take one of these. Well, how many of these do I actually need? So there's one of these, and I need 3 of them, yes? So now I got 3 of them. And of course, what did we just make? And what would that be then? What is it fully? 1 0 0. Do you notice something really cool?
That's just like how base 10 works.
Yeah. So I don't care what the base is. If I'm in base 27, what is 27 times 27 in base 27? 100. Because it's 10 times 10. Do you guys kind of follow?
See that last part?
If I'm in base 27, how do I represent the number 27? If I'm in base 27, what are the places? The ones place? 27's place. So if I have the number 27, I have 127 and 0 ones, yes? So then I represent, in base 27, the number 27 would be represented 1 0. Is everybody with me? How do you represent the number 10 in base 10? 1 0. How do you represent the number 87 in base 87? 1 0.
Because
Meaning-
in base 87,
It would be 187, 0 ones.
so the 87 is the 10 in that particular base.
Beautiful. Let me stop there for a minute. You guys kind of with me? So again, base 87 would have what places? You always have what place starting here? 1. And then you have 87. And then you have 87 times 87. Well, shit that is. Are you with me? So how do you write 87 in base 87? Well, how many 87s are in 87?
1.
And how many left over? There are none. So there's a general statement we can make.
So if you were to base 87 and you had 88, it would be 187 and then a 1.
Yeah, so 88 would be 11, base 87. Alright, but that's not where I'm going.
just wondering.
If I'm in base B, how do you represent B? 1 0, base B, yes. So that's a generalization. So why is the 1 0 represent 10? Because we have a base 10. 1 0 would represent 27 if we had a base 27. So everybody with me? Okay, cool. I forgot, we got me off on that. Okay, we got me off on that tangent. What if I wanted to do? Let's try this. 1, 2 plus 1 base 3. So real quick, to do it visually, do it with the how do you represent 1, 2? Base 3, how do you represent 1, 2? How do you represent 1, 2? You have 1 what? 1 long and 2 units. We call these little dudes units, right? Absolute units, little dudes. Okay. Is everybody with me? And now if I add 1, what do I actually get? 2, 0. I love it. Are you with me? So watch this. Stay with me. Watch. If you want to see like the math behind what we're doing, how do you add 18 plus 2? 8 plus 2 is 10, so that extra 10. So of course later this semester we're going to develop algorithms that lead students to why carrying makes sense. You're not born knowing that carrying makes sense. So a lot of misunderstandings about Common Core is the algorithms you have to take students through so that they make sense. And parents will say, why don't you just teach carry the 1? We just have to get a student to the point where they see why it makes sense, correct? You're not born with it. You don't want to just go, well, you just put the 1 there, kid. No, you want to show them why that happens. So when I hit the base, I carry the extra over, right? I carry that fact that I got a whole base. I carry it over here, there. So now I got 2 bases plus no 1s, right? 2, in this case, longs plus no units. So when I do 12 base 3 plus 1 base 3, 2 plus 1,
3.
so it's 0, right? Carry the 1. Didn't I just make a base? 2 plus 1, didn't I just make the next place? So I got 0 1s, carry the 1, I got 2. And that's exactly what we just got, correct? Right, do it again. So I got 12, base 3. If I add 1 more, that is carrying the 1 right there. You can see the visual of carrying. I'm sorry, if you guys can tell me you can't see. So there's 12, right? 1, 2, base 3. Add 1, well that's in the wrong place now, right?
I get it.
This is the actual physical carrying the freaking 1. It becomes a physical thing. Do you see that? So now I can replace that with bam. And now I got 2, 0. Yes?
Why not put this guy in the 9th place?
Because I didn't get that, did I? You see what I'm saying? So this would mean I have 9 total in our base, right? So this would be 1, 0, 0. I'm nowhere near 100, yeah. So watch this. What if I had, yes, go ahead.
If we were to write, like, if it was 27 base 3, would it be 1, 0? Like, do we have to put all this?
Alright, so if I have 27 in our system, that would be, what would that be in base 3?
1, 0, but do we have?
1, 0, 0, 0, yeah.
Okay, I just didn't know if you actually wrote those.
Hell yeah.
Okay.
Otherwise, I wouldn't know what place
Yeah,
the
okay,
1's in.
that's what
Yeah.
I was wondering.
Yeah. Does that make sense? So that's, of course, the power of the place value system is the more zeros I put, the more important that number becomes. It becomes in a larger place. I like it. Let's do one more to kind of push this over here. What if I had 2, 1, base 3, plus 2, base 3? So try to represent that visually. So I have 2, 1, base 3. Jeff, you need to. Where do you go? There it is. Is everybody with me on that? This is 2, 1, base 3. Is this cool? Okay. Real quick. How quick is it to get this back to our base 10? 1, 2, 3, 4, 5, 6, 7. So 2, 1, base 3 is 7. Do you guys see that? So at any point while you're doing something, you can always say, what is this in our system? What is that? What is this in base 10? 6, 7. It's 7. So 2, 1, base 3 is the number 7.
Can you do that one more time?
What? Okay. All right. Every single one is truly 1, correct? I really want this to make sense. 1 base 7 is exactly the same as 1 base 11, is exactly the same as 1 base 13 billion, right? They all mean 1. So when I do this like this, when I represent that next higher place as truly 3, if I want to go back to my system, I just got to count 1, 2, 3, 4, 5, 6, 7. So what is 2, 1 base 3? 7. Because it can freaking count them, right? Each one is 1 in base 10, correct? So isn't this 1, 2, 3, 4, 5, 6, 7? So 2, 1 base 3 is 7. 2 3s is 6 plus 1, 7. Is everybody with me? A little bit. And remember, everything we're doing right now with these base 3 things, you would be doing with your students with base 10. And then learning the base system just becomes a system, just counting. And at that point, they've learned the counting chant, and they learned the numbers and so forth. Are you guys with me? The basic numbers. 1, 2, 3, 4, 5, 6. Okay. Now what happens if I add 2 to this? What happens?
Everything messes up.
Everything happens, yes?
Yeah.
So this becomes a long, yes? So it comes over here, but then this becomes, what's this become?
Like,
A flat. So what number is it now? 1, 0, 0. And let's see, let's try to do the work. Watch this. If I try to do the work, every time I hit a 3, I've got to carry 1, correct? Same way that if I'm adding 2 numbers and it adds to 10, don't I have to put a 0, carry the 1? Is everybody with me? When I add in base 10, our system, if I add things, then they come out to be 10 or bigger, I've got to put the second digit down and carry a 1, because that 10 goes into the next place. So watch this. What is 1 plus 2? I'm sorry. What is 1 plus 2?
3.
3. I hit a base, so I gotta put a 0, carry the 1. What's 1 plus 2?
3.
Oh shit! 0, carry the 1. Can we stop for a minute? Is this, do you guys start to see? And again, all the trouble you are having now with base 3 is similar to the issues your students will have when they're first learning base 10. Something that non-teachers do not understand is we weren't born understanding the number system. When you get older and you're like, well, yeah, of course it's 5 plus 6, you carry the 1, this shit's wrong there. No, you're not born with knowing this stuff. You gotta see, you gotta progress and catch up with. What does it mean when you put numbers on top of each other? What does that 1 mean? Why would it be there? You know, they don't know, they don't have a clue. So we build stuff, they like toys, they like blocks, they like counting shit. We just naturally have to count shit. Little kids, if you wanna get them to have a big smile, you say, count that and tell me how many, and if they get it right, forget it. So during the semester, I'm gonna show you some videos of little kids working on math problems. And we're gonna discuss kind of like what was the issue, what did they do right, what did they do wrong, what would you have said to them, all this kind of stuff. Are you with me? Now, of course, I forgot my password. I was gonna show this video. But I gotta remember my password now. Anyway, so I'll try to do that. Everybody understanding this stuff here, right here?
Kind of lost me halfway.
Oh, let's do that problem again, real quick. So I've got, let me write the problem again. I've got so much going on in here. So I want to do 2, 1 base 3 plus 2 base 3, right? Is that cool? So represent 2, 1 base 3. 2, 1. This is so cool. I really want you to see it. Again, it's a physical reality of carrying. It's really silly. You don't just put a 1, you actually can see it happening. So if I add 2 to this, what immediately happens? That becomes a long, and it goes over here. That is the equivalent of carrying that 1 right there. Are you with me? That is the equivalent of carrying that 1. But what happens now? These 3 become 1 flat, right? That is the equivalent of carrying that 1. Yes?
Are we gonna get the blocks for the test, or do we have to remember the equation?
For like a test or something, if I do ask your question, you can just draw the blocks. Yeah. Sorry. Sometimes I will have like on the final for sure, I have little stations. So like one problem will say go to station 1 and do what's there. Do you understand what I'm saying? Do you understand what I'm saying? So during the final, you'll all have like slightly different finals. And some of you have this section first, and some of you have this, so that I don't get too many people like trying to come up here. You guys kind of follow? So yes, you will get some of these sometimes, but on like quick little whatevers, you can just draw them, right? I know. Okay. Is that better? What happened? No? Okay. So one more time. So 2-1. Tell me the minute I lose you. How are we doing so far? 2-1 base 3. Add 2. Add 2. Bam. I just added 2. But what does that make? Doesn't that make a long?
That's where you're losing it. You're adding the 2 just because this is 2 base 3.
Yeah, that.
Yeah. So I'm taking 21 base 3. Is everybody with me? I've done 21 base 3 here, right? You guys with me? That's 21 base 3. Yes? Okay. And then I'm going to add 2 base 3. And what does 2 base 3 look like? Like that. What does 2 base 7 look like? That. Yeah. Every place has to have a units place. Every base value has a units place. You guys all with me so far? So here's 2-1 base 3. How do you represent 2 base 3? Like this. How do you add them together? Put them together. So using blocks, it feels like you're playing. It's easy to see visually when you group things. Are you guys with me? Doing the pure algebra, or not algebra, but the computational shit can get very abstract very quickly, carrying stuff and whatever. This is completely visual. What shape did I just make here? And is that where the long's supposed to be? Go ahead.
How come, this is 2?
No, come on. All right, wait a minute. All right, let's back up for a second. Okay. So if I want to do 2-1, I put 2 of these down, yes? This is 1 3, this is 2 3s. Are you with me? Good. This would be 1 9. This would be 2 9s, right? Okay. So maybe I didn't understand the question. Come at me again.
Why are you putting 1 cube as opposed to why is this one, these 2 there and that one, and why this one right here?
Cause that's just what the equation is.
2-1 base 3. What's in the
I can't
threes?
see,
Oh.
your thing is off.
What's in the threes place?
A 2.
Here, I put it here. A 2. So there's 2 things in the threes place. And what's in the ones place? It's 1 thing in the 1 place. Is everybody cool?
It wouldn't be one of these, it would be one of.
So listen, the minute I get this shape from doing something, where does that go? That must go in this place. Because what is this place? This is the threes place, right? Agree with me? Okay.
That is it.
So here's that's the whole key, because watch, when I add 2, what shape did I make now? I made this shape. Where's that supposed to be? There. Carry the 1. What shape did I make?
9.
This shape. Where's that shape supposed to be? Carry the 1. So now I got 1 0 0, right? So that's just like 99 plus 1. Carry, yes? Is that right? Oh, you guys love this, I can tell. Alright. The most fundamental thing you can do, of course, is just throw a bunch of singlets out there, a bunch of units, and just have them group. They group 3s, and then the minute they group so many 3s, now suddenly they got a 9. So as you do it, you replace it with the next shape up. So if they group 3 together, you immediately replace that with a long. Do you see what I'm saying? And one of the very first things, the funny thing is walking around, some of you guys, I love it. If some of you didn't do this, I'd be worried about all of you. But I gave you all those shapes, and you guys are making all these freaking things out of them. Yeah, let your students do that shit. When you're gonna give them manipulatives, let them do whatever the hell, as long as it's not breaking or hurting anybody. Let them just play with the damn thing, just to get used to them. You know what I mean? And then you're gonna go, all right, we're gonna do some specific things with this now. But I really like the duck you made, and really like the weird little thing you made, whatever, right? Just so they get used to just how they feel. You with me? And then you start trying to do some more. Okay, try to group them into groups of 3. How many groups of 3 do you got, or whatever? You guys kind of with me? Yes. Okay. All right. Let me think. Was there sort of it? I don't want to do that yet. That'll be later. I'm not going to do any division. That gets freaky. Okay. All right. So I told you it wasn't going to be much. We're going to do more with this as we go through and learn more stuff later. So let's see if we can all do this in reverse. Did anyone have a question about this before I take them all back? Huh?
We just wanna keep building.
I know. I see. You make it some Jenga thing. Yes.
It's getting crazy. It's reverse Jenga. We're trying to build.
Oh, damn it!
Don't lose any of them. There's one right there.
Wait, how do you visualize these things?
Huh?
How do you visualize
All right.
No, can we not even go there? If we had to do if this was a base 4, we would be using.
Yeah, I got some base 5 pieces. So it's just the ones. You always have the ones. Then I have a long that's 5.
Yeah.
What would the flat be?
10.
5 by 5, 25. Right?
I would
So what are
say-
the places in base 5? 1s times 5, 5 times 5, 25s times 5,
Oh, you lost me.
125. I love the fact that 2 of our rows are cubes, the 125 and the 8. No, okay, it's just me. 1 times 5 is 5 times 5 is 25, and then why does that make, watch this, you ready? Why does that make visual sense? 3 times 3 is 9. So you can see it's the number that would be in the total thing if you put them side by side, right? You guys kind of with me? Later this semester, so I will save you from this, we'll be doing more advanced multiplication using these things, and of course division using these things. Are you guys kind of okay. Later. For right now, we'll just leave it at this. Okay. So, can we try to do this in reverse now? Can you send up one person? I'll come around and get the little units. If somebody can come up and put the cubes and such back in there.
Yeah, together we
Yeah.
Yeah, 'cause ever since you said that division doesn't exist, I've been very confused about math, like how division functions.
Oh, good. As a teacher, you always want to have a student know less.
Yeah, but like.
I'm sorry, that was me.
It's okay, I accept it. You'll be fine.
Oh, cool.
It's only 3 points.
There you go. Who else has units left? Anybody has little bigs left?
How far did you get? It's gonna come with a lot of correction.
I just messed up. Yeah.
Alright.
But it's like, you should be like, teacher, like 2.1, that's the last time.
Alright guys, so if you miss a quiz, does anyone know what happens if you miss a quiz and you tell me that you missed it? What happens? Do you get a 0? Does anyone know? I need the, it's on the
I
syllabus.
think the next quiz, you gotta.
Replaces the grade on the, yeah, so you don't get a 0. Unless you just sort of disappear and then show up on the day of the test, I'm like, so you gotta just tell me, I'm gonna miss, I'm sorry. I don't do makeup quizzes because that would just be too many things to keep track of. So whatever you make on the next test also counts for the missing quiz grade, meaning your test just becomes a little more important. Does that make sense? It's a good trade-off, I think.
I remember that.
Okay. No worries, it's okay. All right. So that pretty much, I forgot all my own stuff up here. I'll get you later. That pretty much is the end of section 2.3. Of course, 2.3 for us, we're not going to have those manipulatives. It's going to be a bunch of calculations, right? Changing to different bases. Let's do real quick a couple of examples before we get into chapter 1.
But I did have a question
Yeah.
about section 2-3, set B.
Yeah.
Number 4, it says set A, exercise 4. Exercise 4, I see like the figures, where are the exercises?
Wait a minute, hold on. 2, 3B.
Yeah, number 4.
So these are exercises, right? Number 4?
Set A, exercise 4.
Sorry?
Oh, duh, okay.
What's
That
happening?
makes sense, that makes sense.
Are you good?
Yeah.
Okay. I'm glad I could be there.
Yeah, can you
While you
start
figured it out
moving
yourself.
our the tests, like the homework, more towards like the problems?
Say again, sorry?
Like the problems, like not in the exercises.
Oh, wait, all right. So the tests and the quizzes,
The homework.
the homework, what about it?
You know how like they all are in like with the exercise, most of them are in the exercises?
Sure.
Can you put it more towards like the problems? Because when the problems, I have an answer key.
Oh. No, everybody should have all the set A. Or not all, is it all, or is it?
Yeah, it's all.
Yeah, it's all of them, we're in the back, yeah. Every freaking answer is set A's in the back. Which explains why I give some an A and some B. So I like to give you a mixture, I like to give you some with a net and some without. Does that make sense?
Yeah.
So I did.
Okay.
So I gave you some with answers and some without. I always do that every class I have. Okay. So let's do a couple of quick examples from section 2.3, and then we're going to talk about everybody's favorite thing. You're working pretty well. So can somebody remind me, like, if I want to go to base 16, so if I have the number 1492, why not? So I got the number 1492, and I want to go to base 16. How do I know what base this is in? Yeah, if it doesn't say, we assume it's us, right? So I want to go to base 16. Is this going to be a relatively easy problem or a relatively hard problem? Oh, well, so what I mean is it's got to be one or the other. So whenever we go to our base, it's relatively easy because they multiply out. Whenever we go from our base to another one, that's going to be relatively hard because all the places are empty. All the places are empty. What are the places in base 16? Ones, 16s, 256?
4,096.
All right, so that's too far, right? Is that cool? Okay. So remember, always, bless you, go one place too far, just make sure you went far enough, right? And then how does this work?
You take 256 and divide it.
Into 1492, okay. Is that right?
No, it's 5.
5, yeah. Trying to do this in my head. So that'll be 1,280? Is that right?
Yeah.
So I got how much left? 212, okay. So 16 goes into 212. 13. Dude, D. Wow. We'll get there. 13 times 16 is 208. So then I just have 4. Now, real quick, there's always somebody that didn't quite get this. If I write this as my answer, why is that wrong? Why is that wrong? Yeah, because then what would the 5 be in? The 5 would be in that frickin' place. And that's 20,000, that is way bigger than that's supposed to be, right? So this is why base 16, any base above 10, we have to come up with single digits that we normally don't have single digits. I don't have a single digit for 10. So of course, you guys remember, what do we use? A. So what's 13? D. And I think I showed you, we found some HTML stuff last
Yeah.
time, yeah. For the colors, yeah. Hmm?
That's mostly why hex decimal's 4.
For why what?
Hex decimal's mostly used for colors.
Oh, yeah, true, okay. Well, it's got a lot of other uses, but that's that's the easiest one to see. What if I, hello? What if I do, 78 to base 2? What's the highest single digit in base 2?
1.
1. 0, 1 stuff, right? This is binary, this is computer language, is what people kind of normally know it as. What are my places in base 2?
1, 2, 4, 8, 16, 32, 64, 108, no.
Whew. So it kind of makes sense. The less value each place has, the larger your number is gonna have to be. So if I got a base 2, normally I'm gonna make a pretty long thing because each place is able to cover less of the number. But if I go from our number to base 16, that went from 4 digits to 3 because each place is stronger, it's heavier. Okay, division. This is gonna be a long ass number roll, right? So how many 64s? 1. What have I got left? 14. Any 32s? Any 16s? Nope. How many 8s? 1. How many 4s? 1. How many 2s? 1. How many 1s?
0.
None. So it's 1, 0, 0, 1, 1, 1, 0, base 2. Yes.
I understand that one, and that one in regards to you got a D?
Yes. So A is 10, B is 11, C is 12, D is 13. Right?
Yeah.
And I really, do you guys see why? If I keep it as 1, 3, I suddenly am lying to everybody. I don't have 4 places, it's supposed to have 3 places. So I need a single digit for a number that our number system has 2 digits for. Shit. Right? Guess follow. So we just chose, it could have been anything. We could have made up symbols.
Could have been circle, star, square.
Huh?
Could have been like a circle, star.
Yeah, a circle and a star or whatever.
In a
Could have been like
problem-
Lucky Charms stuff, little balloon. Yes.
In a problem, would you have like D in somewhere there, or would you tell us what symbol to use?
If I say, so a problem I could give you would be this, convert this to our, okay, Jeff, sure. Convert this to our number system. So base 10. Right, I'm not gonna do this, I'm sorry. I mean, I'm not gonna dab. What place is each one in?
1, 16, oh, 50.
200, I think it's 225.
Yeah.
Okay.
Are you guys with me? So far, all I did was identify the base. If I tell you base 300, you can make the places, what do you count, right? 1, 300, 300 times 300. Making the places based on the base, easy. What's the next thing I should do for myself?
Figure out what the
Seriously.
the numbers are.
Yeah, so this would be 13,
10,
10, 11. So now it's just multiply, add, correct? This is an example of it's always easier to go from somebody else's to ours, because then it's multiply, add. If I go from ours to somebody else's, that's divide, subtract.
And you got the 13 because
D is 13, yeah. So any base, now I will tell you this before I forget, the book, for some dumb reason, when you have base 12, they say 10 is T and 11 is E. You guys kind of with me?
Like, those are their symbols instead
Yeah.
of A, B, C.
Which is dumb.
Oh.
It should just be A and B forever, but it isn't. This book said T for 10, E for 11. Do you see how that immediately dies for base 13? Because then it would be T for 10, E for 11, T for 12. No, see? Do you guys follow? So it's unfortunate that this book for base 12, they will have T's and E's. T for 10, E for 11. Every other base above that, A, B, C, D, E. However far up you gotta go. Say again?
After T and E, they go to A,
No.
they go to C.
No, they only use T and E if it's base 12, and they only have to go up to 11 for base
Yeah.
12, right?
But if it's base 13,
Then they'll use A, B, C. Yeah, A, B, C.
Like for all languages?
Yeah, they just.
I agree.
Start at A.
I agree. Every book's got some issue. Alright,
I think this is the big one on this book.
yes.
I understand like how to do it, but can you explain again, like, just go back to this, it's just, like, why they roll over into the letters? It's because.
So right here,
For that don't.
right here. Do you agree with this problem we did earlier, these numbers? If I did not have a single digit for 13 and I wrote this, do you see how that has 1, 2, 3, 4 places? I'm supposed to have 1, 2, 3. This explains it the best I possibly can. I need a single digit for 13 because I can have 13 things in one place. And if I write 1, 3, that looks like 2 places. Yes?
So if the book is asking us to go to place, 13 or 12, should we write TE or keep it to A and B?
For me, you can write A, B, it's
I
fine.
don't know.
If you check your answer like in part A, they're gonna have T's and E's, yeah. So just remember their T and their E is A, B. So I'm sorry about that, but yeah.
T is 10, E is 11.
Yep.
Okay, awesome.
Yeah, at least that's like T10, E11, that makes sense, but, okay. Alright. So, let's see. Any other questions on this kind of stuff? Different bases? Okay. I like the fact that this book has us do Mayans and Babylonians before we do this, because it's interesting. When we do Mayans and Babylonians, it's interesting. Students seem to get that pretty quick, even though it's base frickin' 60, and then Mayans is base frickin' sort of 20, yes? You guys with me? And then it's always interesting, when I go to base and I'm like, now we can use our symbols. This is what really freaks students out, but I'm like, you guys just did Babylonians and Mayans, and they have weird ass symbols, but for some reason that seems easier. Because I think your brain says, different symbols, everything's hard, and then it's relatively easier than you thought it would be. I think that's what's going on.
Because it's too similar to what we already use, but just slightly off.
Yeah, exactly.
Something
So
completely different.
your brain is okay with the Mayans and Babylonians being kind of hard, so it seems easier than your brain might think it will be. This, you're like, it should be easy. Wait a minute, 13 is A, is D, what the shit? Yeah, okay. But it's exactly the same work. Okay, so what we're about to get into is, I said earlier, very sarcastically, everybody's favorite, word problems. So we're going to discuss different methods you could use. Here's an example of something I like to give to my algebra. So when you're taking algebra, what method do you think you should use to solve word problems? Algebra. Does that make sense? So the example I like to give, so students will often tell me the answer because they figured it out. What method do students sometimes use to solve algebra problems without using algebra, without using like variables? Do you guys know? If I said I have two numbers that add to be 12, and they also subtract to be 4, do you have to use algebra for that? So let me write this down. I have two numbers. They add to be 12, and they subtract to be 4. You could use algebra for this, because don't you have two things you don't know? Isn't that what algebra is all about? Algebra is all about giving names to things you don't know so you can do shit with them. I can't do shit with blank space and blank space, so let me call it X and Y instead. Are you with me? But what's another way you can solve this problem? Guess and check. I love it. The book calls it, just to be different, they call it guess and test. We all know it's freaking guess and check, right? So when a student does guess and check for one of my algebra tests, I tell them an example. If you were in driving school and the final exam was to drive to the mall, and you walk to the mall and you call, I'm at the mall, I did it, you're gonna fail. Because the whole point of the class is driving, yes? If the point of the class was get somewhere, then walking is a valid option. Are you with me? So for us right now, algebra will just be one possible option. So one of the options we have is guess and test, is what the book calls it. I'm gonna probably call it guess and check. So how would I guess and check here? So somebody already got the answer? Yeah. So how did you get it? What'd you do?
I started with like 1 and 11. And
Oh, good, good. So like 1 and 11 make 12, but they don't subtract to 4. So then it sort of becomes like a, I always use this reference. Do you guys get the Price is Right kind of game? Higher, lower. All right. So eventually you get to 8 and 4. Right? They add to be 12 and they subtract to be 4. Is everybody with me? You guys? So that's a relatively easy problem if you're allowed to just guess and check, right? So that is definitely one problem that you can use. One option you can use for solving strategy. Will guess and check be the best way to do problems? No. No. If I said, take a number, double it, add 11, divide it by 3, subtract 7, and you get 12.2. Do you want to guess and check for that shit? No. Because the answer will more than likely be decimal. Are you guys kind of with me? So one immediate reason to not use guess and check is if the answer could be some infinite kind of possibility. Are you with me? Here, the answers could only be certain things. That's relatively quick to go down the list of possibilities, right? Okay. Everybody's kind of with me. I love it. All right, so one option is guess and check. Let's see. What if I had a problem where I said, let me see if you guys are with me on this. How many rectangles with, okay, let me make sure you guys are with me. How many rectangles can you draw with whole number sides? So a side cannot be 7.2 long. Are you with me? Whole number sides, where the perimeter is what did I want? Sure, 10 is fine. Now you might want to add something into your guess and check. What do you want to also do? What kind of makes sense here, dude? Say again?
how many sides there are?
Well, how many sides on a rectangle? 4. So what do you want to do then? To kind of give yourself a visual anchor of what you're working with. Draw a picture, okay. So on some problems, drawing a picture is a huge part of the problem. In fact, on some problems, drawing a picture is the best way to solve it. Now, here is just going to be very helpful. If I draw a picture and start to label it, it just gives me a kind of an anchor to work with, instead of just numbers floating out there. It also helps you to not forget there are freaking 4 sides. Because I'll have students do this. I'll go, well, 5 and 5 is 10, and 4 and 6 is 10. I'm like, no, there's 4 sides. You're just doing 2 sides. You guys kind of with me? So can somebody give me one way? Like, for what if I say this is 1? This side has to be 1, so it's not all slanty, right?
So
Which means how much is left?
8.
So each of these have to be 4. Do you guys see that? So it is kind of like a modified guess and check with drawing a picture. Are you guys semi with me? No algebra? I could use algebra, sort of. Let me stop for a minute. Come up with some more. That's one of them. Don't say anything. Try to come up with some more. Yeah.
Would putting like the ones on the top and the bottom, that count as a set?
Excellent question. We're going to get to it. Come up with some more. Basically what he just asked is, if I put a 1 here and 1 here, is that really different? Well, no, I would just rotate. This is the same rectangle, right? Just rotate it. So I want how many distinct rectangles?
2.
What's the other one?
2.
2, 2?
And then
3, 3.
3, 3. Yeah. Because then the next thing would be 3, 3, 2, 2, but that's this one again, right?
And then 4.
Yeah. What would you tell a student? See, if a student doesn't draw the picture and kind of remind themselves what's going on, they could go 0 and 0 and 5 and 5. There we go. But of course, that doesn't make any damn sense. If one side was 0, it would not be a rectangle. It would just be a line. You guys kind of with me?
Yeah.
Okay. So drawing a picture is sometimes part of how you solve it, and sometimes it is the way you solve it. How we all do it. Okay. Going out of order. I forget where make a variable comes in. Is that now? Yes. Cool. Okay. So then we get the one I keep saying. Algebra, which is really use a variable. So, let me kind of blow your minds a little bit. I want to add 3 consecutive integers. What the shit does that mean by itself? 3 consecutive integers. Can somebody give me 3 consecutive integers? 1, 2, 3. 111, 112, 113, right?
Integer is a line, correct?
No. Integers live on a number line. An integer is just a positive or negative whole number, right? I like it. Okay. 3 consecutive integers that add up to, what do you got, Jeff? I don't know. Let's say 213. Yeah. Yes. Making it up on doing it live. I'm hoping it works. How this shit, all right, there's several ways. If I forced you to use a variable, why do we use a variable? What is it we don't, or how many things do we not know? 3. 3. Are they all independent of each other? No. Give me a number. Any number. Give me a number.
71.
71?
Yeah.
What's the next consecutive integer?
72.
Could that have been any number you want it to be? No. Based on this one, how is it related? Any number you give me, how do you get the next number? Not well, I see what you mean, but like the next consecutive up, I guess is what I'm thinking about. But you could subtract 1, but let's not go there. So if you give me any number, how do you get the next one? You add 1. How do you get the next one after that? You add 1 again. Are you with me? Does anyone know? No. I don't care if you've done any work. The minute you first read this, you haven't done any work with it, do you know what the first number is? No. In algebra. In fact, the title of the freaking thing is use a variable. What are you going to call that first number? X. You could call it square. You could call it happy face. Right? You could call it whatever the shit you want. Just a symbol that represents the placeholder for this thing I don't know. So I'm going to call the first number X. What's the second number then?
X. 2x.
No, I don't double it.
Plus 1.
I add 1 to it, correct? All algebra does is it captures patterns. That's all it does. How do we get from one number to the next? You add 1. Well, the first one's X, the next one's X plus 1. So what's the third one?
X plus 2.
Holy shit.
Equals.
How many numbers do I have represented on the board?
3.
And they are all supposed to do what? Add up to,
213.
yeah.
X plus.
Yeah, so this number plus that number plus that number equals 213.
We don't know what it is yet, though.
Now we can solve it though, right? That's the power of algebra. And I know some of you guys are like, man, I didn't think there'd be any algebra in this kind of, well, yeah, there will be. How do you do that? How do you solve that?
So.
Yeah, how many x's do I have on the side?
3.
So I got 3 x's, and what's the numbers?
3
3.
equals 213. And then subtract 3.
Subtract 3, I want to get the x by itself, right?
3x equals 210.
So now I got 3 times something is 210. To figure out what the something is, I just divide, right?
Yeah.
3 goes into 210 70 times. So what are the 3 numbers?
70, 71, and 72.
Does that sound familiar to anybody? Yes.
Do you like it, like, do you like getting it your way? Cause I found a different way to get it, same answer.
I was gonna ask.
Yeah.
Okay, so I said,
Wait, can we write this down real quick?
Oh, yeah.
no, of course.
Yeah.
I'm just reminding everybody what I said. I said one way to do this is by using a variable. If I force you to use a variable, how would you do it?
No, I use get the variable. So,
I see, okay.
Yeah.
Hold on.
Okay.
Would we write x equals 70, 71, or no, never mind, it's radical. Okay.
So look at this.
Yeah.
Now, of course, this is not algebra class. We're not gonna get deep into this kind of stuff, okay? Just to kind of put you at ease a little bit. But do you notice the biggest mistake students make in algebra when they learn word problems is they don't do this step for themselves. And then they try to set up the equation. Normally that's wrong, and they don't know what to do with the answer. So look, 3 things I don't know. The minute I know x, I also know these other 2, bam, bam, bam. So if I do this, I set this up right, and then I know what the hell to do with the answer. So it's really kind of like, I don't know why it's so hard to get them to do this. Like, yeah, you'll go quicker. You'll get to the wrong answer really quick. You know, but I'd rather get to the right answer, so. Now, so what'd you do?
I divided 213 by 3.
Okay, good, so you did not use a variable.
Oh, yes, cause I knew that.
You didn't, you shouldn't have.
Oh.
So, if you divide 213 by 3, you'll get
71.
71. That by itself is not the answer, correct?
Yeah.
But what does this mean? Doesn't it mean 71 plus 71 plus 71 is 213, right? You guys with me? So if I take one away from this, and I give it to this, I get the answers, right?
Yeah.
I'm sorry, I should have let you say this, what you did, right?
Yeah.
Okay. Do you guys see that?
How did you know to do that?
It's an approach somebody can take.
Yeah.
So here's the thing. I took a painting class once, and there were people around me that had been painting their whole life. So they knew a lot of tricks. They knew how to hold a brush to make, they knew which brush to make certain things happen. They knew how to mix exactly the thing. Here's Jeff. I didn't know the little tricks and so forth. The more math you're exposed to, the more you know the boundaries. You know how much flexibility there is.
That is an acceptable way to do it?
Hell yeah. If I did not say you must use a variable, right? Now you say you used a variable.
Yeah.
Where?
So I knew to get the x pretty much would be the difference of 213 divided by 3, and I knew that would be x. I know, if you take 1 away from x, and then if you add x.
Okay, sure. That's more of an idea. You didn't really use the variable.
I didn't need to use
Yeah.
the variable, I just know how to use the
When
variable.
getting a variable, can you go, you got the second one first, like how did you,
Second one, how do you mean?
you got a second number, cause you divided.
Over here. This
Yeah.
approach?
Well, how did you know when to put the x or what to do with it?
All right. Are you talking about just this?
Yes.
Do you agree with me? There's 3 things we don't know. So isn't there a first number, a second number, a third number?
Yes.
So the first step in any word problem is use the English to identify the players. That's what I call them. I call them players. What are the players in this problem? 3 things. First number, second number, third number. That's the English names. Now give them mathish names. Right? I don't know any of them. So let me say the first one is called X. I got to give it a math name. Now I can write what the second one is. It's one more than that. Right? Any number, what's the next number? That number plus 1. Are you with me? So once I call him X, I can build everything else.
So how did you get 71 with x plus 1?
No. We didn't have that yet. What are these 3 numbers supposed to do?
Get us to 213.
So if I add this one to this one to this one, I get 213.
Yes.
And then I solve that. Yes? And I get x equals 70. So don't I know x is 70 now? Right? So your problem is here? Okay.
Right, like, I guess where you begin.
X plus x plus x
Yeah.
is 3x.
Yes.
1 plus 2 is 3. Right?
Right.
And when you're solving equations, you get your x's on one side and your numbers on the other side, so that's why I subtracted 3, right? So 3x equals 210, so I just divide by 3. You see what I'm saying? And that's how I got 70. Then I come up here, x is 70. So what's the next number? X plus 1. Well, if x is 70, this is 71. If x is 70, this is 72. And then I can check it, and sure enough, it adds up to be 213. Okay. waning few minutes left. How do I write every even number? What is the property of every even number? Every even number, what can you do with any even number? Any even number, what do they all have in common?
Divide by 2.
You can divide by 2, correct? You with me? So that means that if I wanted to make an even number, couldn't I give you any number I wanted to, and you could do one thing to make an even number out of it? So if I said 3, couldn't you just double it?
Yeah.
So isn't every even number double something? 2 is double 1. 14 is double 7. Are you guys kind of with me?
Yeah.
So if I wanted to represent every even number, I could just write that. That is every even number.
Is that an N?
That's an N. Yes. N just stands for natural numbers. 1, 2, 3. What's the first even number?
2.
1 is odd, yeah. So the first even number is 2. What would I make N to get it? 1. You were 1 ahead.
Even.
Huh?
Is 0 even?
0? No. It depends. We normally consider. See, I'm cool with 0 being even, but there's a lot of places where 0 is just not, right? Sort of like, is 0 negative or positive? Yes, no. It's both and neither at the same time, so that's neat. I guess, let's not talk too much about 0. 0 always makes things weird. So how would I write every odd number?
N. What, like, 1, wait, or no, 3.
Give me an even number. Give me any even number.
6.
What odd number is that next to?
7.
5 and 7.
5 or 7, right? So what could I do to 6 to make it odd? I could either subtract 1 or add 1, correct? 2n minus 1. Do you understand why somebody might say 3n? I was wondering if somebody might say 3n, because
Yeah.
if 2n is even numbers, somebody would go, well, 3n must be odd numbers. But no, that doesn't work, does it? 3 times 2 is 6. Oh, shit.
You can also do 2n plus 1.
2n plus 1, sure, yes. That'll work in general. But then I have to let n be 0, so I can pick up 1. Does that make sense?
Why do you have to double it?
To make it even.
Yeah, so
Could they already be even?
really, here's the key.
Or is it odd?
Every even number is how far apart from the next even number?
It's
2. 2 apart. So there's just steps of 2, right?
No, I
Every-
know that. I just.
No, I just want to make sure everybody gets this. Every odd number is how far away from the next odd number? 2. So that's really why there's a 2 in both. You should go by 2, but here, if you start at 2 and go by 2, you got all the even numbers. Here, if you start at 1 and go by 2, you get all the odd numbers. That's why they're offset by 1. Is that cool? So if I wanted to say, if you add an even and an odd, will it always be odd? So you could do some examples. If you add an even and an odd, will the answer always be odd?
Yeah.
Give me an example.
3 plus 2.
3 plus 2 is 5, 11. You could list 18 trillion to the trillionth power examples, and you still haven't proven it. Examples don't prove shit. Examples disprove shit real quick, right? Examples can never prove something. So how would I do that? Do I have every even number up here on the board somewhere? Yes, I do. I have got every even number on the board right there. So if I take an even number, now let's be careful. Let's see if you guys pick up on this. And I want to add it to any other odd number. So why can't I do this? Is that any other odd number?
No.
I really want this. If that's 6, what number is this? 5, right? You guys with me? So what, I don't want to use the same letter there. Do you guys see that? Otherwise, they're based on the same thing. I want them to be whatever the shit, I want to be able to add 6 to 211. Even number to odd number. So there is every even number, there is every odd number.
And M and N are just letters you're using.
N and M are like 1, 2, 3, 4. That's what I build them off of, right? Yes.
So then the bottom would be 2m minus 1, or it would still stay as 2m?
The bottom?
Yeah, every odd, like when you originally
Yeah.
wrote it.
Yeah, so this would be sort of like the general idea.
Oh.
If I have both of them showing up at once, I really want this to make sense. If I had a rectangle and I don't know this side, I can call it X. If I call that side X also, is that a rectangle?
Square.
That's a square. Would I have to use a different letter?
Yeah.
Okay, good. So if I say this is 2n, that is a specific number. If I say this is 2n minus 1, that is related to that number. But don't I want to have any freaking even number and any freaking odd number? I want them to be their own thing, right? So real quick, last thing. Could you factor 2 out of this? Isn't that in the form of an odd number? Twice something minus 1? So that's a proof. If you add any odd to any even, you will get an odd. That's a proof for it. So it's another thing that using a variable is good for. Okay. There's a lot. Don't freak out. Don't freak out. And listen to me real quick. Listen to me. I need to make this really clear. The big thing with all the word problem section, the entire chapter 1, the big thing is, do you understand the methods used to solve them? Getting the answer is bonus. So if you can show me you understand the method, but then you're not sure exactly how to get to the answer or whatever, you're going to get most of the points. I need you to understand the process. Answers are bonus, because we're not actually building bridges yet. Nobody's going to die if we get 7 and we're supposed to get 70. Right? Yes?
So that was 2.1. I mean, that was
1.1. Yes.
starting away.
When I started talking about the ways, we got guess and check, use a variable, and draw a picture. Those are the 3 methods in section 1. Oh, cool. Don't forget your IDs or stuff. Please.